Hi folks, Mr. Long here. A screencast for computations on algebraic computations for derivatives of the inverse. So this is like number 3 on your homework. And so one of the things that often gets done notation-wise is in a question they'll say, let f to the minus 1 of x, call it g of x. So you just, I guess they do it so you don't have to keep repeatedly saying f to the minus 1 of x. So what we know then is that we know g of x is the inverse of f of x. And this question says, calculate g prime at x at the indicated ordered pair on the inverse function. Okay, so the original function is given here, x cubed. The ordered pair, though, is on the inverse. Okay, and that's g of x. So it's kind of weird, right? We have an algebraic equation for the original function. We have an ordered pair on the inverse. So we want to get the tangent slope on the inverse. So that's the x value we want to get the tangent slope at. So let's zoom in on this one a little bit so we can follow through it. So first thing I did, of course, is you get the derivative for the original function. F prime is 3x squared. So what's our goal? There's our goal right there. We want to get g prime, the tangent slope of the inverse, when x is 64 and y is 4. So what's something that we know automatically? Well, automatically we know that if 64, 4 is on the inverse, 4 and 64 is on the original function. And I'm going to do this part. I'm going to get the slope of the inverse without actually getting the derivative of the inverse, right? By those nice relationships. So my goal is to get g prime when x equals 64. How do I write that? G prime at 64. But I know that g prime at 64 is the reciprocal of the tangent slope on the original function at the corresponding value. So 64, 4. So if this is 64, this has to be 4. Okay, so all I need to do is to substitute 4 into the derivative. And the derivative is 3x squared. So that's 4 squared here is 16. 16 times 3 is 48. So our answer is 1 over 48. And that's approximately 0.02. Okay, let's look at the next question. So on this one, it says that our original function is root x. I did the derivative of root x, 1 over 2 root x. The ordered pair where we want the slope is 4, 16, and that's on the inverse. But remember, we're calling the inverse g. Okay, so our goal is to get the slope of the tangent on the inverse when x equals 4 and y equals 16. Well, if 4 and 16 is on the inverse, I know that 16 and 4 is on the original. What do? If I want to get g prime at 4, which is the tangent slope on the inverse at 4, I know it's equal to 1 divided by the slope of the original function at the corresponding value. So it's going to be at x equals 16 on the original. Okay, so what do? I replace f prime with the f prime formula, which is 1 over, I'm going to just quickly erase that. There's part of that that's right, but part of it that's not right. So let's think about this for a second. So it's 1 over, and then the derivative is 1 over 2 root x. Well, in this case, x is 16. So what is the square root of 16? Well, it's 4. Times 2 is 8. So really what we've got is 1 over 1/8. And I can do the reciprocal of the bottom and multiply, or I can just know that 1/8 goes into 1 8 times. Okay, so that is the slope of the tangent on the inverse function when x equals 4. Okay, and that kind of is intuitive because root x, the inverse of root x is x squared. The derivative of x squared is 2x. At x equals 4, 2 times x is 8. Okay, so again, that process is the same every single time. And once you get the hang of it, I think you're going to understand how to do it pretty intuitively. So if you notice, I'm not even using generalized formulas. I'm just doing it with our understanding of inverse functions and derivatives. Okay, I hope that helped.